Okay, so what about number 14? Number 14 clearly is not a sum or a difference of two cubes, but what we want to be able to do with number 14 is be able to solve it by a technique of grouping. That's this guy right here in your textbook, and we did this in the notes. Now, there's only a small handful of you that actually was with me when we did this in chapter 4. Some of you, depending on which teacher you had, called this master product. And factoring with master product involves you grouping up the first two terms and grouping up the second two terms and doing greatest common factors with those. So here's what you're going to do with number 14. Okay, so first things first with grouping. Grouping works when you are no. A good sign for grouping is when you see a polynomial that has four terms. So the first thing you're going to do is you're going to group up the first two terms and you're going to group up the second two terms. Do you notice I put those in brackets and not parentheses? I see this at least once or twice a year from students when they try to do this problem. They will do this, where they'll have the x cubed and then the 2x squared. They'll set this problem up wonderfully. And then instead of put brackets like that, they'll put parentheses here to symbolize the group. And here's exactly what they will do next. They'll get somehow distracted. For some weird reason, something might happen. They write this down, and then all of a sudden, squirrel! And then they get distracted. And then all of a sudden, everything's back to normal. And then they get back to this. And then you know what they do? They go, okay, now with the parentheses, I'm doing x cubed times 5x squared, and here comes 5x to the fourth. Do you see what we're doing now? We're doing first, outer, inner, last, which is the worst possible move that we should be doing here. We should not be foiling this. So, one of the things I stress to students on these problems is to not do that. And the best way to fight that students from from foiling and multiplying those together is to put brackets on it instead of put parentheses on it. In fact, I'll go one step further. Not only put brackets around those two, but do this too. Right underneath each one, write this. Greatest common factor and greatest common factor. That'll remind yourself to take the greatest common factor of each one of these rather than multiply them together. So do you notice what I wrote down for the greatest common factor for each one? The greatest common factor of x cubed plus 2x squared would be x squared. Greatest common factor of 5x plus 10 would be 5. Okay, so then your next move is to take that greatest common factor out of each one of those two groups. So there I've set up the first one. I take out x squared and see the parentheses. What's inside those parentheses is what is the remaining factors or quotients, if you will, depending on which point of view you take, of when you take the x cubed plus the 2x squared and divide it by x squared or factor it out, which is what you would get right here. You'd end up with x plus 2. An easy way to check your answer is a distributive property. X squared times x gives us x to the third, and x squared times 2 gives us 2x squared. You do the same thing for the next group. Okay, we factor out the 5 in that plus sign right there, and what needs to go there? X plus 2. Some of you alums, Mr. Cook alums from last trimester, do you remember how do you know we did this right? Is this right here, is when those guys are the same. When those two are identical, you did this right. Because once again, now you have another greatest common factor. Okay? Out of these two guys, this here, plus sign, that guy right there, we have a greatest common factor of x plus 2, which we can now factor out of each one of those. Okay? And then we'd have x plus 2 times x squared plus 5 equals 1. Okay? Where'd you get the x squared plus 5, x squared plus 5, Mr. Cook? The stuff that wasn't in the parentheses. Okay? Realize if I were to do the distributive property once, do the distributive property again, I would get that group right up here. I would get all that. True story. So then, here's what happens next. You set them both equal to 0. X plus 2 could be equal to 0. Or x squared plus 5 could be equal to 0. And then you solve each one of those. Look at that move. See how I'm subtracting 2 from both sides in the first one? Let's subtract 5 from both sides in the next one. Now when we do it on this side over here, we're done already, right? X must be equal to 2. We have one of our solutions. We do it over here, we get x squared equals negative 5. We're not done yet. We did not solve for x. So our next move needs to be taking the square root of both sides. When you take the square root on both sides, realize you have two answers there, plus minus. And then do you see what I did right there? Factored out that negative 1 like we should, so that way we can get the proper imaginary answer of plus minus I square roots of 5. There's our three solutions right there. So that's how we factor by grouping, ladies and gentlemen.